Well, hello, Year 11. It's the last lesson of the term. How's it going, folks? Don't forget to say hi on the chat so I can do the register. How's everyone feeling today? There we go. Hey, Elijah. Hey, Julian. Look at that. First people in. Yeah, Julian's in. Elijah's in. It's nice to see you guys. I've got Ange, got Ira, got Meryl. Yeah. Doing well. We're nearly done, folks. We're nearly there. Marcellus, so I love the fact that he's just gone, oh, no, done this before. Hey, Marcellus. I keep thinking you write Sup, but it's your surname. I'm so sorry. Oh, it's funny. Oh. Today, folks, we're going to be doing a bit of revision on energetics. I should probably put it in the title, really, shouldn't I? I've just put GCSE revision, and it doesn't really doesn't help, does it? Not knowing what the topic is. If anybody searches back over these, they just won't know what to read. So I'll edit that after the lesson because we're going to be looking at energetics today. Only 4 people here so far. It's after break time. You guys should have all been waiting. Should have been waiting. Hey, Sian, thanks for coming along to my Year 10 lesson. I know that you probably found the empirical stuff all a bit easy. I made a right mess at the end of that lesson. I made up a question and it didn't work. Oops. Yeah, it was my fault. Should never make up calculations questions. Hey, Minwei. Good to see you. Hey, Michael. Hey, Liz. Hey, Hibbert. Yeah, everyone's turning up now. Whoop, 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 whoop. Got Hibbert. Who else have I got? I've got Michael. I've got Liz. That's a bit better, isn't it? Got a few more now. 8 people. Still missing loads of people. Anyone heard from Audrey? Yeah, I know that she's not been to a couple of lessons. I don't know whether or not she's here watching. It'd be really useful if you know. Okay. Missing loads of people today. I think everyone's ready for a break now, aren't they? I think everyone's ready. It's been a long term, this, hasn't it? And lockdown is not helping. Not helping at all. Nope. Hey, there's MJ. Ashy potato. Oh. Hey, Meryl. I literally asked you guys in the chat. Hey, sir, aren't IGs cancelled? Yes. Ignored me. Adam, yeah. So IGs are cancelled, yes. But hey, Harry, good to see you, dude. But the problem is, you see, you're still going to need to be showing that you're making an effort, Adam, because your teachers are going to need to be giving you your grades. And when we go back to school, the school is preparing for return of school after the holiday. Hey, Isha, nice to see you. Isha's in. Yay. Mark Isha is in. Missing Mavella. Missing Catherine, missing Russell, missing Emmeline. MJ, can you stop it, please? Come on, guys. I have no idea what's going on between you guys. Drama, eh? Drama. Such drama, Adam. Right, what I'm going to do is I'm going to start the lesson. I'll mark the others as not in. Missing Aisha, missing Morella, missing Tom, missing Catherine, missing Russell, missing Emmeline. Okay. Sir, we would not be having a remock, right? It's possible. Morella's here. Oh, okay. It's Morella here. It's very possible, Harry, that you will end up having a second mock when we go back. Yeah, it's very, very possible. Because we're going to need to submit evidence. Luckily, I've kept all your mock papers, which is great. So I have the evidence of those. But if we go back to school, if after the Easter holiday, the lockdown is over, if we go back, you guys won't have real exams, but you will have a mock exam. Yeah, we will give you another one. Sian, I don't need you, like, you guys know that we're going to be using all the evidence that I've got, and I have, we're going to be looking at all your reports and everything and looking at the data. You guys know all the data that I collect. I will be using all of that data, yeah, to be being able to show that you guys have made outstanding progress. Don't worry, okay? But yes, you will. If we go back, you will have a second mock. It will happen, and us teachers will mark it. Okay, so let's crack on with today's lesson, folks. The personal cancelling exams. MJ, no, it doesn't. The exam boards have cancelled it because the exam boards are worldwide, and places like the US and the UK are becoming a growing problem with the coronavirus, whereas other places are not quite as severe. And I kind of understand, you saying that doesn't it defeat the purpose? I do understand that, but in this regard, no, not really. Like, we need to supply evidence for the grades that we give you guys, and if we're back in school, then we will give you guys a second mock to be able to support that evidence. So yeah, it's just going to be another piece of evidence that we can submit. But other schools won't be able to do it because in the UK, it's not going to be off lockdown. Schools won't go back. US won't go back. So so they're realizing that across the world, it's so variable that they can't run these as legitimate exams because it would be unfair. Some people wouldn't be able to do them. So they've just cancelled them altogether. But if we're back, then we'll be able to provide additional evidence with a remock. That's all. Right, folks, let's crack on then, shall we? So I'm going to share my screen with you guys. There we go. We're in. So today's lesson is we're going to be looking at, so is this applicable for all three sciences? Harry, if we go back, most subjects will be doing some form of a remock. Most of them will be. So, over Easter, you guys need to be doing some revision. The revision is not over for you guys. I don't want you to think that it is, because it isn't. Far from it. Yeah, but if we go back to school, you guys will have remocks probably for everything. So be doing the work over the Easter holidays. You guys also know that, you guys, for me, have just been one of my best all-time classes. Oh, hey, Emmeline, thanks for coming. Best all-time classes, and I will do everything I can to support you guys through this. You know, I'm at home now over Easter. If you guys are struggling with a topic in chemistry and you want me to be doing a webinar, I'll do one. You know that. How do you manage to be late to everything? You guys know that I will always give you guys a webinar if you need it. Always. Yeah. What I'd actually like to do, guys, is I'd like to go through some exam papers in preparation as if it was a mock. So if you guys want, we can choose some right now. Let's go to the GCSE document of mine. Yeah, let's go to, I can never remember how to find this. If I go to my GCSE sheet that I've created for you guys, this is always tricky for me to drive. Yeah, and I can choose a paper. In fact, we can choose a couple. Let's try and do at least 2 papers over the Easter holiday for you guys, and then I will go through them on a webinar. So, and I will schedule it. In fact, I'll schedule it now on my YouTube, so it's there and waiting for you guys. Chemistry support sheet. GCSE tracking sheet complete. I think I even hyperlinked in some of the super booklets for you guys. Yeah, I did. Wowza. So obviously, just wait for the sheet to finish loading. There we go. If we go to paper 1. So what I'd really like, guys, is as I said, you guys know I'll always support you with all of this. My laptop's just being so slow. There we go. So what I'm going to ask you to do, I'll just highlight this. Let's choose a paper, shall we? Let's choose a paper for you guys to do. I want you guys to have a go at this paper here. So that's paper 1 and paper 2. I'll highlight that in yellow. There we go. Can you guys have a go at 2015 regional? Yeah, and also can you also have a go at, I don't know, the 2016 regional as well? I think that's very reasonable. Very regional. see what I did there. It's regional, reasonable. No? All right. But can you guys have a go at this over Easter? Yeah, do those 2. And I will do the 2015 at the end of this week. So today's Friday. I will do it next Friday. Yeah, a week today. So have a go at paper 1 and paper 2. And then I will go through those 2 papers on a YouTube webinar. Yeah, I'll probably do it in 4, maybe 3 pieces, because paper 1 is so long. Yeah, and I'm very aware of that. So this is Easter week 1. And then this one can be Easter week 2. There we go. So you guys can have a go at those over the Easter holiday, and then I'll go through them. Hey, Tom, it's good to see you. I'll mark you as in. There's Tom. Amazing. Right. So let's go back to today's lesson. Let's get it done. So energetics, this is general energy calculations. And the title today is energetics. And that is really important that I continue to focus on that word. Whoa, it's a fat pen. Let's make it thin. This is energetics. And we know that energetics is all about exoendo. Yeah, exoendo, otherwise known as mexobendo. Yeah, making bonds is exothermic. Breaking bonds, yeah, is endothermic. Breaking, and that wasn't even mine, that. Making and breaking bonds. So it's all about exoendo. It's also then about calorimetry. Now, this is the practical. Yeah, that's a prac that you're going to need to know about. Yeah, that's Q equals MC delta T. It's the calorimetry prac. And then we also have bond energies. We've got burp. Yeah, this is, I'll put bond calculations, bond calcs. And I'm then also going to say graphs. Yeah. So this is what I'm going to hopefully do in this webinar, but I'm going to do the calculations, just work through some practice questions with you guys first, and then I'll look at the graphs and we'll try and tack on some of those questions. So the worksheet that I've put on, and by the way, shall I put this on the classroom so that you guys have access to this? That's probably a good idea, isn't it? No, that one, no. Oh, I've lost it. Lost my classrooms. Hang on one sec. I'll put this on the classroom so that you guys can then be doing it with me rather than writing down answers for random things. I'll do that now. Give me 1 second and I will post it. Yeah, so 11C. Let's do classwork. This is partly because I didn't... Ira asked me to post the previous one. I'm just going to do energetics questions. I'll do webinar. I'll add that file. Select, and then I'll do general energy calcs. There we go. Upload. Right, so you guys now have access to this on the classroom. So if you guys now want to open this up, yeah, it just saves you having to write down any questions. Not that it really makes a difference, but you know, it's better that they're there. There we go, they're up. I like it. Okay, so let's go through question number 1. So as soon as I see specific heat capacity, first thing I'm going to realize is that this here is calorimetry. Yeah, calorimetry. I'm just going to quickly mention the practical. Yeah, so what are they doing in this? They are doing, the mass is 1 centimeter. In an experiment, butane gas is completely burnt in air and it's going to raise the temperature of water, 100 grams of it. Right, so what does this look like in a practical? So a calorimetry prac, and by the way, this is one of the essay questions that they often like to do. They will say, give the steps in the process of calorimetry. Yeah, how you would measure the energy released from this. And in this case, we've got butane gas. Now, butane gas is what's used in lighters. So if I actually draw a lighter, well, I'm not doing very well today. If I draw a lighter, here's our lighter. Yeah, and we've got this little thing. I don't know. Yeah, so there's our button. We're going to press the button down and we're going to get our flame. And it's said to burn completely. Yeah, so our flame would technically be blue. And we're also then going to, of course, get... so there's our... This is butane. Butane gas is what's in as I said, in lighters. So what we're now going to do is we're now going to try and catch, because we know that the heat from this is going to escape. Yeah? So we now need to catch it. In calorimetry, it's the idea of catching it. And what we're going to do is we're going to catch this in water. Yeah, we're going to catch this in water. And they've given us 100 grams of it. So I'm going to set up a really tall tripod. And I'm going to catch this in a beaker containing 100 grams of water. Yeah, H2O, and I've got 100 grams of it. Right, now what we're going to have to do, to be able to do this practical, number 1, we're going to have to weigh butane lighter, before experiment. Experiment, nice one. I don't know who's Didney? Don't know who that is. Weigh butane lighter before experiment. Then we're going to measure the temperature of the water. Measure temp. Russell. Ah. Hey, Russell. Good to see you, dude. Great job. Good to see you. There we go. So we're going to measure the temp of water before the experiment. Before experiment. Right, now we're going to perform the experiment. So measure the weight of the lighter beforehand, measure the temperature of the water beforehand. Yeah, there we go. So we're then going to heat this up. We're going to light the lighter. We're going to heat it. And it then says that and let's give some figures for this. So we're going to say that the weight of the lighter beforehand was, let's say, 14 grams. The temperature of the water was 21 degrees Celsius. Very reasonable. And then they then give us, in our question, they tell us that 0.4 grams of butane. So now we're then going to run experiment, run EXP. Right, then we're going to weigh the butane after. Weigh butane lighter after. And that's going to weigh 13.6 grams. We're then going to measure the temperature of the water. Yeah? Measure temp of water after. And they told us in our question that the temperature went up by 54.2. So afterwards, 54.2. There we go. So the water now has a temperature of 75.2 degrees Celsius. Now we can work out the energy that we've captured. So what we can now do is the two steps that we've got to do here, folks. So step number 1 in calorimetry. Yeah, step 1 is always Q equals MC delta T. And this is for water. Yeah, this is for the water, folks. The first step is all about the water. Yeah, this is water. It has nothing to do with the fuel. Nothing at all. That's the second step. So Q is raw energy in joules. Yeah. Mass that's the mass of water. This is the heat capacity of water. And this is the temp change. Yeah, temp change of the water. Right, let's run it through. Q equals, what was the mass? It was 100 centimeters cubed. 1 centimeter cubed of water equals 1 gram. So I've got 100 grams of water multiplied by the heat capacity of 4.2 multiplied by the temp change of 54.2 degrees. Right, so Q equals, first thing, 100 multiplied by 4.2 multiplied by 54.2. And I get a number of 22,764 joules raw energy. Right, now what I've got to do is this isn't really a second step, but I do teach it. The first thing you've therefore immediately got to now do is divide it by 1,000, yeah, to put it into kilojoules. Now, I'll tell you why in a second. Yeah, the reason being, step 2 is all about getting now the fuel in line. So we now go, the enthalpy change, delta H, equals Q over N. Let's explain what these bits are. So delta H, this literally stands for enthalpy change. Now, I don't like the word enthalpy, and I never liked it when I was in school either. Yeah, what that actually translates to in real English is heat energy change. Yeah, and heat energy is measured in kilojoules, hence why we needed to convert per mole. Now remember that per actually means divide. This is an equation. And that's what we're doing here. Yeah, Q is in kilojoules. It's nice to highlight those. Kilojoules is now Q, and per mole, and N is moles. Everyone knows that N stands for moles. Moles is grams over rams. N equals G over MA. You know that, or RAM. So we've got an equation now to use. So what we now need to do is we can say, right, I'm after delta H, and I now have Q. I can insert Q straight away, 22.764 kilojoules. But now the problem is I need to divide it by the moles. And this is the fuel. So we burnt 0.4 grams of butane. Right, so number of moles is grams over rams. Right, so 0.4 divided by, what does butane weigh? C4H, double it and add 2, 10. So 12, that's going to be, carbon is 12 times 4, add that to hydrogen is 1 times 10. Yeah, so 12 times 4 plus 10 is 58. So over 58 for butane. Right, let's run it through our calculator. 0.4 divided by 58 gives us, so we've got a number of moles of butane of 6.8, rounds 2 sig, 3 sig fig, yeah, times 10 to the minus 3 moles. But I'm not going to take that number off my calculator. Hey, Victoria, lovely to see you. Right, so now I can put this into here. So I can now say delta H equals 22.764 kilojoules divided by 6.90 times 10 to the minus 3 moles. Yeah, and I'm going to get, so I'm going to do 22.764 divided by answer. I haven't taken that number off my calculator, and I get a final answer of 3,300 kilojoules per mole, and I'm done. Yeah, there we go. I hope that all made sense. So there's the answer. Let's have a look at how this question now does it. So they've broken it into pieces. Calculate the heat released in kilojoules. They've broken this into pieces in this case. They're asking us to run Q equals MC delta T here. MC delta, shouldn't do a capital M. Q equals MC delta T. Yeah, so that now gives us the 22,000, whatever it was, mass of water, 100 multiplied by 4.2 multiplied by 54.2. And I get 100 multiplied by 4.2 times by 54.2. And I got 22. The most common mistake is people will forget to leave that because that comes out in joules and you've got to divide it by 1,000 to put it into kilojoules. Just watch out. Calculate the heat energies per gram. Oh, look at that. They're telling you literally how to do it. 22,764 divided by the grams. The grams of butane was 0.4. Divide that by 0.4. Hang on, divide by 1,000 first. Put it into kilojoules on my calculator. Then divide by 0.4. So I now get 56.91 kilojoules per gram. Yeah. Do you notice that it's giving you the units are telling you how to do it? Yeah, it's giving you the equation. Calculate the moles burnt. Number of moles is grams over rams over 58. 0.4 divided by 58 gives me 6.897 times 10 to the minus 3. Don't like that. 3 sig fig. 6.90 times 10 to the minus 3. Times 10 to the minus 3 moles. And then they're just asking you to do that calculation again. Kilojoules per mole, 22.764 over 6.9 times 10 to the minus 3 gives me my answer of 22.764 divided by answer. And I get the same answer again, 3,300 kilojoules per mole. I hope that makes sense. Yeah, but it's nice to talk through the practical. By the way, we all know that these practicals are garbage. Yeah, the biggest problem with this practical problems, number one, heat loss. We know this. Yeah, heat loss. Number two, incomplete. Oh, they've said it was complete combustion. So we can't really do that. 4.2, the heat capacity. You're not just heating water. Yeah, heating metal as well, metal and glass, as well as water. Yeah. All that jazz. We recognize all these. Side reactions, incomplete reaction, all that stuff. Could have been side reactions. Let's do the next one. In an experiment, 0.5 gram of glucose was completely burnt in air. The heat given off raised the temperature. So calculate the heat given off, kilojoules. Q equals mc delta T. So the mass of water, this is all about water, times by 4.2, the heat capacity of water, times by a change in temperature. Oh, guys, I've just made a mistake. Did anybody else catch it? I made a mistake. Come on, year 11. You see, it's just hit me, and I've just fallen for a classic trap. Yeah, I'm sorry. The heat change. I've made a mistake. My laptop's being really slow right now. Yeah, I wonder if it's... Oh, no, it's on full performance. I've forgotten my minus sign. I could have lost that final mark. Yeah, the reason being is this is exothermic. That's a really easy thing to miss, folks. Yeah, even I missed that. I've been teaching 15 years and I still missed it. Yeah, it's negative because the temperature went up. It's exothermic. It's really easy to miss that. Just suddenly realized, suddenly clicked with me. Yeah, times by the temperature of the water, 36.1, right? 50 multiplied by 4.2 multiplied by 36.1 gives me 7,581 joules, but they've asked for me in kilojoules, so 7.581 kilojoules. Next, if it said three significant figures, I'd just get rid of the 1. Calculate the heat released in kilojoules per gram. So I'm going to do 7.581. It's telling me exactly how to do it. Divided by the grams. I burned 0.5 grams of glucose. Divide that by 1,000 on my calculator. Then divide it by point. That's the same as times by 2. That is 15.162 kilojoules per gram. Now calculate the moles. Number of moles is grams over rams. Glucose, 180. Gotta love glucose. 2.78 times 10 to the minus 3 moles. Right, now kilojoules per mole. So we've got kJ, which is 7.581 divided by 2.78 times 10 to the minus 3. So 7.581 divided by answer, and I get an answer of 2,730 kilojoules per mole, but don't forget it was exothermic. So easy, easily missed. Yeah, does that make sense? Hope that makes sense. Right. So it's just nice to do a couple of those questions. Right, the next one is much more tricky. We're now looking at burp. Yeah, we've been given bonds. Look at that, we've been given an equation. Yeah, we've been given an equation. We've been given data. Look at our data. CC bonds, that strength, CH bonds, O's. Been given all of our data. Yeah, we're always going to get given that at iGCSE, which is great. You don't need to pick it up in the data sheet or anything. It's just there in the question. Just got to apply it. Right, split. Now this is bond data. Bond data is reactants minus products, otherwise known as burp. Yeah, I like to teach burp. It's just an easy way of doing it. Yeah. I should say it's BORP because it's bond data instead of BU. BORP. No. So this is just reactants. So I'm going to split my equation in half. So what I need to do is I need to calculate how much energy it costs to smash all of these things. So these are my reactants. These are my products. So let's break some bonds, folks. Right. So first thing I need to do, I'm going to do the breaking bonds is endo. So I'm going to do this one in blue. So I'm going to smash these bonds here. Some CH bonds. How many bonds am I smashing? I'm smashing 8 of them. So CH, now CH is 412, and I'm smashing 8 of them. Yeah? 412 times 8 gives me 3296. Right, how many other bonds am I breaking? I'm also going to now break these bonds and these bonds. I'm breaking a CC bond. Now, a CC bond was 348, 348, and I'm breaking two of them. So I'm going to do 348 times 2. It's going to give me 696. Right, now I'm going to break this bond here, the O double bond, 498. But I've got 5 of them. Yeah, if there was a big number here, I would have had to have multiplied all of these up by 3 as well. But obviously there wasn't. So, but there's 5. I'm breaking an O double bond at 498, but I'm breaking 5 of them. That's the most common mistake. Yeah, 2490. Let's total it up, folks, for this side. So I've got 3296 plus 696 plus 2490. So the total is 6482, and it's endothermic. Guys, what time does school end today? 12 o'clock, Ange. 12 o'clock. This is your last lesson. It's the last one, Ange. It's the last one. Okay, so, and that's endothermic. That's endo, because I'm breaking bonds. Mexobendo, breaking bonds is endothermic. We got physics test. That's hilarious. You shouldn't do. Shouldn't be a lesson after 12. School ends at 12. Anyway, so next, we now need to break bonds. Now I need to make bonds. And making bonds is exothermic. So I'm going to make him and him. C double bond O. But the thing is, there's 2 here. There's 2 of them. But I've got 3 of the molecules. So in total, I am making 6 of these bonds. That's the hard bit here, folks, at 743. Yeah, 743 times 6 gives me 4458. The next thing is I need to also make these 2. There's 2 per molecule. I'm going to make OH bond, and the OH bond is 463. But I now have 2 per molecule, but I've got 4 molecules. Yeah, so I've got 8 in total. Yeah, so I'm going to make 463 times 8. 463 times 8. Damn it, calculator's not working. 463 times 8 gives me 3,704. Right, that's all I've got to make, folks. We have to submit it today when school starts. Oh, right. By the way, Mel checks 11.2 chat. Anyway, so let's work out the total, folks. Let's total it up. Plus 4458. Total output 8162, and that's exothermic. So now all we do is go, we actually don't even need the sign when we run burp. Yeah, bond data is reactants. So I'll do that in blue. Yeah, you don't even need to worry about the signs. 6482 minus, this is where I want to just color code everything, minus products 8162. All the signs minus 6482 minus 8162, and I get an answer of minus 1,680, and it is exothermic because it's negative. Right. Explain why the reaction is exothermic or endothermic in terms of breaking and making bonds. Right. Dead easy. So, more energy. I'm going to make my pen smaller. Yeah, more energy is released. More energy is released when new bonds made compared to energy absorbed in breaking bonds. You're done. Yeah, that's it. More energy released when the new bonds are made than is used in breaking the original bonds. You're done. That's it. Right? They've given you another one. Just got to run it. Same thing, folks. Divide it in half. Yeah, so bond data equals reactants minus products. Right, these are our reactants. These are our products. Let's smash all the bonds. So zoom in on this side. So we're going to endothermic breaking the bonds. There we go. So I'm going to first of all break him and him. So a CH bond. CH bonds are 412, as you can see up here. Yeah, and there are 2 of them to break. Total, 412 times 2 gives me 824. Right, I now need to break this guy, and there's 1 of them. Wow, CC triple bond. CC triple bond. So I've got a 1 CC triple bond times 1, and that value is 837. So there's only 1 of them, so 837. Next, I've got 1 of these bonds to break, but there's 2 molecules, so I've got 2. A H bond times 2, where's HH? 436. 436 times 2, 436 times 2 gives me 872. Right, add them all together. 824 plus 837 plus 872 gives us, it's gonna take 2,533 kilojoules of energy to break all of the bonds. Next, what am I now gonna make? Let's do them in red. Yeah, so I need to smash him, and him. How many are there? There are 6. There's no big number either, which is great. So I've got CH bonds we've got to make, and they are 412, and I have 6 of them to build. So 412 times 6 gives me 2,472. Next, I also need to make that bond here, 1 CC bond. CC is 348 times by 1, which is 348. Add them together. 2,472 plus 348 gives me 2,820. Cool. Right. Reactants minus products. So I'm going to do that one minus that one. 2,000 minus answer gives me minus equals minus 287. It is still exothermic. Kilojoules per mole. Wait, I'm energizing and readying my brain cells to figure out what to type. Okay. Next, explain why this reaction is exo or endothermic. I feel like they were trying to give us an endo one here, folks. Hydrogenation. It's still exothermic by the looks of it. Triple bond's crazy strong. CH is times 2. 1 hydrogen, but it's times 2. Looks all correct to me. 824 plus 837 plus 872. Yeah, that is correct. Yeah, well, it's still exothermic. It's still negative. I'm going to say total energy. Come on. My laptop's really struggling today. So total energy to break bonds is less than total energy, is less than the total energy released when making. We're done, same thing. I think that brings us to the end of the worksheet. Amazing. Is that the end of the lesson as well? How are we doing for time-wise? Are we actually way ahead of time here? Oh, no, not really. 10 minutes early. Right. Let's go. Let's bring it all back to this. Hey, guys. We're done. It's all over. I hope you found it useful. I know that you guys clearly have a physics test which is on your mind much more than chemistry. So I will leave you guys be to do your revision. Guys, I hope you have a really, really lovely holiday. I know that no one's going to be going anywhere and it's all a bit depressing being under lockdown, but it's great to see you guys. I really wish you guys a really lovely break. Do the work and I'll see you in a week. So I'll see you a week today. I'll even schedule it on my YouTube channel, so it's there and waiting for you guys. And I'll see you. Hopefully, I would really, 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 really like to see you all in a week. Yeah, I really hope you guys all can attend. Guys, take care. Miss you loads. See you soon. Trying to